Hello everyone, I am Dr. Pallavi Ram. Welcome to my channel Probabilistic Revelations for Engineering. This is this video is about total probability and Bayes theorem. So let us look into what does the law of total probability tell us. So let us say we have an experiment and the sample space of that experiment is omega. And let us say the events A1, A2 and so on till AN, these are all mutually exclusive and they form the partition of omega. Now, partition stands for the union of all these events A1, A union A2 and so on union AN being the complete sample space itself. So when this happens, then we say A1 to AN, all these events are a partition of omega or partition of the sample space. So now the total probability law says us that if there is any arbitrary event called B, then the probability of B can be written as probability of B given A1 multiplied by probability of A1, probability of B given A2 multiplied by probability of A2, and till the last one, probability of B given AN multiplied by probability of AN. So this law, we call it as total probability. So let us try to prove this law. Now, if we want to write the probability of any arbitrary event B, we can write it as probability of B union omega. B intersection omega. So that's because B has some few of the outcomes of the sample space, but omega is a sample space itself. So B intersection any sample space omega will always be B itself. So hence we can write this as probability of B intersection. The sample space is created because of this partition. So we can write this as A1 union A2 union and so on union AN. So thus that can be further expanded as B intersection A1 event union B intersection A2 union and so on union B intersection AN. Now we know that A1, A2 and so on AN, they are all mutually exclusive. So hence B intersection A1, B intersection A2 and so on, these are also mutually exclusive. Why? Because A1, A2 have no elements in common. So when B intersection A1 is done, then the answer elements will not have anything from A2 means will not have anything from B intersection A2. So same reasoning if you apply to all other events, you can see that these are mutually exclusive. So hence invoking the probability third axiom, we can write this as probability of B intersection A1 plus probability of B intersection A2 plus and so on plus B intersection AN's probability. Now, if we observe each one of these terms is joint probability. Now, we can expand a joint probability using conditional probability like this. Probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2 and probability of B given AN multiplied by probability of AN. So you can observe that this probability of B is exactly the equation that we have seen in the beginning. So thus we can prove that the law of total probability is written in terms of many other joint probabilities, and these joint probabilities can be further expanded in terms of conditional probabilities. Now, we can also write another probability of A1 given B as probability of A1 intersection B divided by probability of B. And this is probability of A1 given B multiplied by, we will write it as probability of B given A1 multiplied by probability of A1 divided by probability of B. Now, the law of total probability, if we replace here, this is called as Bayes' theorem. So now we will dwell a little deeper into the examples of where conditional probability in the form of total probability can be used. So indirectly we are seeing an application on this law of total probability. So let us consider an example. So think that we have two boxes, box B1 and box B2. This has, let us say, 3 white balls and 4 black balls. And this has, let us say, 6 white balls and 8 black balls. Now, one ball has been replaced from box B1 to box B2. So one ball is drawn from B1 and kept in B2. Now, we need to find what is the probability of a white ball drawn from box B2. So one ball has been removed from B1 and placed in B2. Now we should find out what is the probability of white ball drawn from B2. So let us call this event as some C. So we can write this answer like this: probability of C intersection two mutually disjoint events called A1 union A2. Now let us say A1 stands for drawing a white from B1, from box B1, and A2 stands for drawing a black from B1. So drawing a white from B1 and drawing a black from B1, these are mutually exclusive. And A1 intersection A2 is definitely a null set. And that's the reason we say they are mutually exclusive. And same way, A1 union A2, it forms all the balls in box B1. So hence it represents the complete sample space. So we can write this, or we are writing indirectly, this is probability of C intersection the sample space, and the sample space is none other than A1 union A2. So we can write this as probability of C intersection A1 union probability of C intersection A2. So this is none other than, again, these two are mutually exclusive, and hence we can write this as probability of C intersection A1 plus probability of C intersection A2. So these are joint probabilities which give us probability of C given A1 into probability of A1 plus probability of C given A2 multiplied by probability of A2. So this is exactly, these lines, whatever we saw now, these are exactly the proof of total probability law that we have seen previously. So the probability of the event C is now probability of C given A1, means probability of white drawn from B2 given that the ball that has come is a white ball. So that means white from B2 given this A1 stands for white is drawn from B1. So this is our A1 event drawn from B1. So white ball, what is the probability of white ball drawn from B2? So we are removing. But we know that white ball is already drawn from B1. So white ball has come here. The meaning is white ball has come here. So if white comes, total white balls will be 7 and total black balls will be 8. So this probability will be 7 by 7 plus 8, that is 15. And same way, probability of A1, that means probability of white drawn from B1. So from B1, white comes with only 3 out of 7 possibility. So that means this is 3 by 7 plus probability of, this stands for probability of white from B2 given black from B1. That means black ball is replaced in B2, sorry, black ball is kept in B2 from B1. So let us write this. So now we know that a black ball is kept in B2. So this implies we have a total of 6 white but 9 black. So hence this probability, given that ball from B1 is black, we have a total of 6 white balls, but we have a total of 15 balls, out of which only 6 are white. So this event has a probability 6 by 15 multiplied by probability of A2, means probability of black from B1. So from B1 we have only 4 black and out of total 7. So hence its probability is only 4 by 7. So hence probability of white drawn from B2, that is C, event C, is none other than this 7 by 15 into 3 by 7 plus 6 by 15 into 4 by 7. So thus joint probability, conditional probability, joint probability, all these have been mixed up while writing the total probability. So thus problems on total probability is seen in this video. Thank you very much. If you have liked this video, please click the like button. And if you haven't subscribed to my channel, please subscribe. Thank you again.